This material introduces the first steps in modeling a software system. Software development is made up of phases, which are often organized into cycles. The first of these phases is requirement specification. In this particular unit, you will explore how to analyze the requirements document, the output from the requirement specification phase, to arrive at an understanding of how the proposed software system will be structured. The first step in structuring the system is to model the system domain in terms of a collection of classes and the relationships between them. The system domain is the real-world context specific to the software system being developed. These classes are conceptual classes, not the software classes that will eventually form part of a working system. They are modeling elements corresponding to real-world entities. The relationships between them represent connections that are important in the system domain. The classes and relationships should all be ones that the client who has commissioned the software can easily relate to. This picture of the system domain as a collection of related conceptual classes will be referred to as the conceptual model. Once you have drawn up the conceptual model, you will use it as the basis for a series of models of the structure of the system, which will lead eventually to a specification of the software that is to be implemented. The process which takes you from the requirements document to the conceptual model involves the following activities. Identification of those real-world entities described in the requirements document which are concerned with the core functionality of the system, leaving out considerations of the user interface. These will become the conceptual classes in the model. The process of constructing a conceptual model starts with an analysis of the requirements document to identify those entities which are of key significance to the system, excluding any that are irrelevant or peripheral to its core functionality. Having identified entities that are of key significance to the system, we need to identify their properties and the various relationships between them. For example, in the case of a hospital system, patients are likely to have properties such as their name and age, and to be related to wards by virtue of the fact that each patient is on a particular ward. Identification of the conditions that will be imposed on the model. It is also necessary to identify constraints on the system domain, that is, limitations on the entities, their properties, and relationships, and decide what conditions such constraints will impose on the model. Finally, representation of the model using diagrams and associated text. The completed conceptual model will consist of a diagram representing the system domain, together with text describing important features of the model. We create a conceptual model that looks object-oriented because it usually corresponds to real-world entities. The conceptual model will provide an initial basis for the structure or architecture of the software, the classes and objects that make up the system, and the way in which they fit together. That is, the conceptual model gives rise to an initial structural model for the system under development. It is important to recognize that, whilst on paper the conceptual model and the initial structural model may look the same, but they are not. They model different things from different perspectives. A conceptual model is a representation of the system domain, whilst an initial structural model is a plan, an early model of the software itself. The broad real-world context in which the software under development is to operate is known as the business area. This encompasses all the entities and processes, systems, and subsystems that contribute to the activities of a business or other organization, as well as the communication between them. For example, the hospital system could be viewed as one subsystem in the general business area, which covers everything that goes on in hospitals, that is, the dispensing of medicines, the training of nurses and doctors, and so on. Each of these activities may constitute a subsystem which may or may not be computerized, but which will need to communicate with other subsystems in the broader area. The system domain is the particular subpart of a business area for which a software system is being developed. The entities in the system domain are those of potential significance for that system. For example, you know from the requirements document that the entities which form part of the system domain for the hospital system include doctors, patients, and wards, but not nurses and medicines. Finally, that part of the software that is separate from the user interface and that contains objects corresponding to those in the system domain is referred to as the core system. We will present some terms and notation associated with the process of analyzing the requirements document. Several of these will be familiar to you from your knowledge of software implementation. A class models a category of real-world entities from the system domain. Although these may be tangible real-world things, they may also be intangible things such as events, roles, and organizational units. Whether the entities are tangible or not, the modeling elements that represent them are referred to as objects. Objects of a particular class may have properties called attributes corresponding to properties of their real-world equivalents. For example, an object representing a car entity may have an attribute that corresponds to the color property of a car. At any given time, an attribute of an object has a value, that is, specific information that the object holds in respect of that attribute. For example, the color attribute of an object representing a particular car may have the value red. Objects may also have links to one or more other objects, representing connections between real-world entities. If objects of one class can be linked to objects of another class, there is an association between the classes.